Today I want to show you the future of checkout forms in progressive web apps using the Browser Payments API. Instead of giving users a long, tedious checkout form that they're likely not to finish, we give them a simple Buy Now button that uses a credit card saved on their browser, so it behaves a lot more like in-app payments do on native mobile devices. This is very recent technology, and it's only available in Chrome and Microsoft Edge. To facilitate this feature in Angular, we'll be using Stripe Elements, which has the added benefit of supporting Apple Pay on Safari browsers. If you're new to the channel, make sure to subscribe, and if you're serious about payments, check out my full stack Stripe Payments course, which you can find on angularfirebase.com, and is free to all pro members. To build this payment request button, the first thing I'm going to do is start with a fresh Angular 5 app. At this point, you'll also need a Stripe account, and you'll want to reference the payment request button in the Stripe documentation. What we're building is just a simple component that has a random product I found on Amazon, and then when the Buy Now button is clicked, it will bring up the Browser Payments API. When the user clicks Pay, it's going to send the payment information off to Stripe, and Stripe will respond with the payment source. You can see we have a source ID here in the console, as well as information about the user's credit card, but no information that would actually be a client-side security risk. Now, jumping into our Angular code, the first thing we'll have to do is add the Stripe.js version 3 tag to index.html. Stripe.js has its own Stripe class, so we need to register it with TypeScript in typing's DTS. From there, we need to instantiate Stripe somewhere in our project. To do that, I'm going to use an Angular service, which I'm calling the payment service. After we generate it with the CLI, we can go in there and instantiate it with our Stripe publishable key. For the sake of simplicity, I'm using the key directly in the Angular service, but a better approach would be to manage your keys in your Angular environment. That way you can use your test key in your development app and your live key in your actual deployed production app. Now we can build the actual component that's going to do all the work. I'm calling it the payment request component. Because we're using Stripe elements in this component, we need to wait for the view to initialize before we can actually attach the payment button. To do that, we use the AfterViewInit lifecycle hook in Angular. We're also going to bring in our payment service, and then we'll initialize a couple of input variables first. The amount will be the amount of the payment that we're making, and the label is whatever we're paying for. The input properties allow you to use this as a child component. For example, if you had a shopping cart, you could easily pass the total amount and label of that cart down to the child component. From there, we're going to set a few variables for the information that we get back from Stripe elements, including the elements object itself, the payment request, and the payment request button. We'll see these in action in just a minute here. Then to actually mount the element in the DOM, we use the viewChild decorator. Quickly, I'll jump over to the HTML to show you how that looks. ViewChild is pointing to a template reference variable called payElement, so all we do is set up an empty div here and then do #payElement. This div is going to be replaced by the actual Stripe Elements button. Switching back over to the TypeScript, we'll first inject the payment service in the constructor. Now we have about 5 different steps we need to go through, which I'll explain to you one by one. The first step is to instantiate the payment request object. That object has a number of different parameters that you can pass to it, but the two we're going to pass to it for right now are just the amount and the label. We can access Stripe from our payment service and then call payment request, and we'll set the country, the currency, as well as the total amount and the label. Again, the amount and the label correspond to our input properties. Step 2 is to instantiate the Stripe Elements object. Elements contain the actual UI components that we get from Stripe.js. That's just an easy one-line statement. Then we can move on to step 3, where we actually register an event listener for when the user submits their source to Stripe, and Stripe responds back with the actual card details. When Stripe responds with the card details, that's the point when you would send a request to your backend to actually charge the card or just save the card on a customer account. That's a whole nother challenge to overcome, so for right now I'm just going to console log the event, and then I'm going to set a timeout to simulate the call to the backend. Normally you would use the Angular HTTP client to make a call to your backend, but for right now I'm just going to pretend that I received a successful response and then call event complete success. You could also call event fail here, or a number of other validation errors provided by Stripe. The next thing we do is create the actual instance of the UI button from Stripe Elements. So we say elements create payment request button. Then we tell it to reference the payment request object that we've already created. This part's optional, but you can also control the style and the theme of the button. Just pass it a style object and then set the corresponding options that you want. That takes care of step 4. Now the final step is to mount the actual payment button in the DOM. To do this, I'm going to use an async function. You could technically use RxJS here, but I don't think there's really any advantage to doing so. The purpose of this function is to see if the browser supports the payments API. To do that, we say payment request can make payment, which is going to return a promise. If we get a positive result, then we can go ahead and mount our payment request button to the native element that we retrieved from viewchild. Otherwise, the result is going to be null, so we can just console log a helpful error message. Now let's go into Chrome and test it out. We should be good to go, right? Well, not exactly. It looks like our button is not showing up here, and we're getting an error message from Stripe saying that we need to be serving over HTTPS. The problem here is that the Browser Payments API only works when you serve with an SSL certificate, and that goes for development on localhost as well. It is possible to run ng-serve with an SSL certificate if you happen to have an SSL certificate lying around, which not many people do, and a self-signed certificate is not going to work either. Luckily, there's a pretty easy solution, and that's a service called ngrok, or at least I think that's how you pronounce it. It allows you to create an HTTP tunnel that will allow you to serve your app on localhost while also forwarding it to a valid HTTPS connection that you can use with the payment request API. You need to download the application on your local machine, which is going to vary by operating system, but the setup is really easy overall. Once you have it set up, you can create a custom command in your package.json file to run this command quickly. The actual command you use might look a little bit different because you have to point to the actual ngrok install on your local machine. Then you call http 4200, and I also had to set the host header to 8080 for just some random error that was coming up. Once you have that done, you'll first want to run ng-serve, and then you'll open up a second terminal tab and run the npm run ngrok command that we just created. That's going to open up this window that's going to take you to the other side of the tunnel. The one we're looking at is the HTTPS endpoint that is forwarding from localhost 4200. You can go ahead and copy and paste that into a browser, and then it should magically bring up the payment button that we had created before. The forwarding process is really slow, but it does give you a reliable way to test the payment request button. Like I said at the beginning, I believe this is going to be the future of payments in the browser. It makes life so much easier for both the developer and the customer, and things like that tend to be adopted pretty quickly. If this video helped you, please like and subscribe, and if you're serious about payments, consider becoming a pro member at angularfirebase.com. You'll get access to the Stripe Payments project, which is designed for developers who are building Stripe features into real-world applications. Thanks for watching, and I'll see you soon.